Hello everyone again. This is my fourth stream. And this time I'll continue the work from last time, since the PageRank implementation took a bit longer than previously. But this time I did a little bit of preparation. So I've coded the entire single-threaded PageRank example, and I'll just go through the code and hopefully explain everything in the best possible way. And yeah, this time it will take less than an hour, hopefully. So we won't be here for too long. As usual, please ask questions in the chat below. So far there is no questions, so I think we can jump in. Let me switch to the code. Hopefully you can see my screen now. So here we have, actually this is the build directory. I'll go a bit back. So basically I've just extended the example from last time, and yeah, I'll just go through all the details in the code and then run all these examples. And yeah, an idea is to compare this code implemented in C++ with the Python code, and hopefully also with so this here is a single-threaded implementation, very simple implementation, basically, as I think the simplest one that can be. But I'll also try to download a parallel implementation from our GitHub repository and then run that at the end of the stream. So let me quickly explain what is going on here. So this is the standard procedure call, and right, that gets graph from Memgraph, graph stored inside Memgraph, and at the beginning here we initialize mapping between our local context, our local stack, and Memgraph. So we have two data structures that store IDs. So in Memgraph we have one set of IDs, and as the data set is changing, nodes can have different IDs. But once the PageRank is running, then of course it's wise to copy these IDs and to make local IDs just for calculating the algorithm, and then at the end it just makes sense to do the mapping back. So here we have two maps. Actually, I mean, the first one is an array that stores mapping between local IDs and the Memgraph IDs. And then we have another map which stores Memgraph IDs to local IDs. So we need both of these to calculate the algorithm, then return the results that are relevant for the user. Also, last time we actually did populate this data structure. That's the count of all outgoing edges for each vertex. That's something that can be pre-calculated, because in every iteration of PageRank there is a need to know that number and to use that number to in the calculation of the rank. Also, let's just skip this part for now. What we need to pre-calculate before, I mean, what we can pre-calculate is a list of incoming edges or vertices for each vertex as well, because because PageRank takes into account all incoming edges, and based on that, the rank for an actual node is or vertex is calculated. But since first we need first we need the entire mapping, so local to Memgraph and Memgraph to local mapping, and this part of the code here does exactly that. So this is a bit boilerplate code, but I was thinking how to improve that, and maybe for the next streams I'll actually improve this part of the code, because it's very repetitive through the entire algorithm, through the entire procedure. But for now, this just takes an iterator through the vertices in a graph. And this is a deleter, and we are iterating through all the vertices. We get memgraph vertex ID by calling this function, and we populate a local to memgraph map by putting that vertex ID in an array, in the array. And also, since memgraph to local map is a map, we also store under the key mg vertex ID current size of the map -1, because we will use local IDs will just be on the right offset. So the first node that the first vertex that is iterated, it will have index local ID 0, and the second one will have 1. The third one will have 2, and then we can just calculate that by subtracting 1 of the size of the local to MG map. If this is not, I actually made a mistake. If this is not -1, then segfaults happens, and it's not pretty. So usually, yeah, this when there is a C++ code there, you have to take care of these map IDs and how do you access an array. And then, okay, so since in this block of code we are iterating through all vertices, at this stage, at this step, we can also fetch all outgoing edges and then calculate, then sum how many of them for each vertex exists. So we are just counting how many outgoing edges a vertex has, and we store that again also at the end of that array, outcount array. And that's it for now. So at this stage here, we have the mapping and outgoing counts pre-calculated. So they can be used as the algorithm gets executed. And that's wise to do, because PageRank has many iterations, so many times the same data is required, so it makes sense to store that somewhere and then reuse it later. Since we have to store our local IDs for each, local neighbors of each vertex, we need to calculate these, calculate the mapping initially, and then in the second phase here, we are traversing the graph again. So this code here is exactly the same as the previous one. Very equivalent to the previous one, but the goal here is just to build an array of adjacent vertices for each vertex. And that's for incoming ones. So because PageRank depends on on how many incoming edges a vertex has, then we have to store that information as well. And in vertices. So this is declaration and partial definition of this in vertices array. So for each there is a vector that has another vector inside for each vertex. And since we know exactly how big, so how many vertices are in the graph, we can just like pre-define or pre-allocate the entire vector. And we do this that here just by calling a constructor of this vector and putting the size of the local to MG map here, and also adding initialization of the vector, because vector has many vectors inside. This could be done a little bit in many ways, and we could probably initialize that vector at once, since we are traversing the graph in the step above. But I think this is fine for now. And then again the same. So we are getting iterated through all vertices, the same code as above, and then in this step here, we're just getting the vertex ID, because we have the vertex from Memgraph, and we need back the local ID, and then we are storing that local ID to the vector of neighboring vertices. That's more or less it. That's more or less that what is going on. And at this point here, we have everything pre-calculated. So we know how many nodes are there, how many vertices are there, what's the count of outgoing edges, and what are incoming edges or vertices. I'm probably I will talk about nodes and vertices. I'm constantly switching between these two, but they are equivalent. And then finally we got to the PageRank stuff. So this is essentially the entire algorithm here. We have a couple of parameters. So max iterations tells how many iterations PageRank will run in total. So if PageRank actually cannot converge, and this parameter here is just to force like stopping at some point. If algorithm doesn't converge, we just break everything and we return results as they are calculated. Dumping factor and stop epsilon. Dumping factor, that's I explained that in the previous video, I think, or maybe even in the second one. So it's just a constant that ensures some statistical properties. So, and it's usually 0.85. So that's pretty much constant all the time. And stop epsilon is also once. So PageRank is calculating, the algorithm is calculating the rank in multiple iterations, and then the epsilon is like a difference between previous iteration and this iteration. And if that difference is smaller than the epsilon, then we basically conclude that the PageRank reached an end for that vertex, and we can stop the algorithm. Iter, that's just an array and a variable that stores a number of like current iteration of the algorithm. Then we have a flag to continue iterations. So yeah, this is just a little bit of, we actually can delete that probably, but yeah, in any case, so that's irrelevant for now. Number of iterations, what's the actual difference between iter and number of iterations? Do I use this? Oh, I have two variables here. That's very interesting. Let me just check this. I'm not using that variable anywhere else, so I think this is something from the past, so I think I can delete that. I'll just comment this for now. But yeah, it's irrelevant, so I can delete this, I think. And that will still be good. So iteration, continue iterate. So continue iterate is false here. If and then the here in the iteration step, we go through all the nodes in the graph, and we set the rank to 0 initially, and then we fetch all in neighbors or incoming edges, and for each of it we have to calculate a ratio between the rank. So I didn't explain that because I jumped in. So basically here we have like two vectors, one for calculating the current rank, and then the rank, and then we also need the rank in the next phase. So we actually calculating the rank in the rank next, and we store the previous iteration ranks in the rank vector. So here we just add the ratio between rank of a neighbor, and then the rank is divided by the number of outgoing edges for that neighbor. That's from the formula, and that's calculated for each incoming edge. And then here we just multiply that by the dumping factor, and then here we just add the initial factor, or the initial number from the formula, and then the vertices count is here just to normalize everything to 1, and that's basically it. And then here we just calculate if the previous rank minus current rank, if the difference between these two is bigger than the stop epsilon, then we're gonna continue iterating next time as well. And yeah, if all the ranks are, or if all differences are smaller, then the epsilon at this point continue iterate won't be updated. It will be false from here, and that while loop will stop. And then after that, we just swap rank and rank next, because we will use rank next to calculate this next iteration of the PageRank. We increment the iteration number, and we just check for max iteration, and then we also put this flag to false. And that's basically it. This part here is also just to normalize everything at the end. So it is just normalized by the sum of everything. So we take all the sums of every rank in the graph, and we just divide each rank by the sum. And that's basically it. So after that, we just this is code from the last time, just a little bit extended. So here we have I'm actually, from this procedure, I'm returning more stuff. So I'm returning local ID, Memgraph ID, out count value, in count value. I mean, in count is just to check, but it could be an array. But I just returned, for the simplicity, just the number of incoming edges. And then we have the rank, which is taken from the rank vector, and yeah, we store that in the result. So we create another record, and then we store that in the result. Result is an object received when the procedure is called. And here, yeah, we have all these columns listed here. So Memgraph ID, local ID, in count, out count, and rank. And that's it when it comes to theory. If you have any questions about anything from the code, I can go back at any time. I'll now just calculate the PageRank. I'll just run this. Let me just initialize a bit. So this is from before. So here, if you can see here, I'm compiling the modules I have. Let me just clean this a bit so we don't have anything here. If I run CMake, that's okay, and I run make. So at this time, we have the PageRank module available. I'll just print the size of it just to showcase that as well. So Memgraph PageRank actually has 187 kilobytes, but that's in some compile mode. So let me just change the compile mode. So I'll do that by running ccmake. That's another tool that can be used to configure CMake projects. If I run here, so it has a variable CMake build type. So if we put here release, and then we have to hit C to configure and G to generate. And if I run make now, so this time PageRank has 37 kilobytes of memory. So this is the release build now, and this should be used for production purposes because it's much faster than anything else, and it also consumes less memory, which is also important because it's easier for computer to fetch instructions from the module. So and just to showcase another option, so instead of release, we can put here debug, configure, generate. If we make now, this time we have a lot bigger size of a module. It's almost 500 kilobytes in size. So this is debug mode, and that's gonna be slower in execution. Okay, actually now I jumped, I skipped one step, but anyways, I'll just run this. So here we have docker run command, and we are just mounting the folder where we have the PageRank module, and to the /PageRank inside the Docker. Oh, I can actually move myself here. So just so you can see. So we have Docker run, and then we are mounting the build folder to the PageRank folder. Actually, I can make this bigger a bit. So we are mounting build folder to the PageRank folder, and then standard flags for the port, and then Memgraph and query modules directory. It's updated to the PageRank folder, which is mounted here. And we also add also log to standard error flag. So if we execute that, so I'm hacking here a bit. I'm loading the entire build directory, but yeah, Memgraph is just ignoring all these other files which are in the build directory, but the module is actually loaded. So I'll go back to the I'll go to the lab, and if I run mg procedures, it says PageRank run is here and has all these return types. So in count, local ID, memgraph ID, out count, and the rank. Rank is the most, so memgraph ID and the rank are the most important ones. So just to showcase a simple example, I'll go back to the code. So we had an examples in the second stream, I think. And I'll just use that as an example. So this is a simple, very simple graph that gets created from the examples from the web. I should have an empty graph, and yeah, now we have 4 nodes and 5 edges. Just to see. Match n return so this is the actual graph. So page C has a bunch of has a 3 incoming edges. Page D doesn't have anything that points to it. So page D should have the lowest page rank, and page C should have the biggest one. Let me go back to the actual query. So page A, B, C, and D. Yeah. Then let's run the actual PageRank. So PageRank.run calls the PageRank. Since we didn't add parameters, all the parameters are hard-coded in the code. I didn't have time today to do that as well, but yeah, if parameters should be changed, that can be added pretty easily here. But yeah, we have, so the node, memgraph node 0, that's node A, has 1 incoming edge, that's B has 1, C has 3, and D has 0. And if you take a look here on the ranks, page D has the lowest rank, and page C has the highest one. And I think this is aligned at what we got when we run a NetworkX PageRank implementation last time. That's great. So let me just run another example with slightly bigger graph. So if I go back, just to refresh mind a bit. So previously we loaded this dataset with cities, countries, and roads. This is available here, and queries are available here on the on Memgraph's blog post. And I'll just go back and load that. So I've prepared that as well. So if I go under here, let me just. So here is Memgraph console. Already attached to, even though I think it's gonna detach me because I restarted Memgraph. Yeah, because I restarted Memgraph, it says there is some exception, so I had to rerun the query again. So I deleted previous dataset from Memgraph, and here I'll just run a import of the entire dataset. So creating indexes on country name and city name, and loading country, cities, and roads. That will take a couple of seconds, and while this is executed, I'll just quickly fetch queries. So nodes are in, and we need just edges. Edges are also in, and that's the dataset size, so it's fine. And let's go back to the here. Actually, I think this should be smarter to showcase here. So if we call the PageRank here, so this will call the PageRank here. So if you remember, this here is our module of PageRank compiled in the debug mode, and we're gonna execute now the calculation. As you can see here, it took 50 milliseconds to calculate the PageRank. So it has these parameters epsilon 0.8, but that's not important. And a maximum number of iterations is 100. And what else is? And epsilon is 10 to the power of -6, I think. And here we calculated all the PageRanks. And that was super fast. And my idea was to showcase what's the difference between this and the Python implementation in NetworkX. So let's go back a bit. To do that, I have to actually restart. So this was our module, and here I'm gonna just use Memgraph PageRank module, which is already in, which is already included in the Docker package. I have to move. If I execute this, so at this stage, I should have that loaded. Okay, procedures, mg procedures, again the same. So okay, and there are all NetworkX procedures loaded. Since Memgraph currently has one query modules directory, so it's hard to load all the modules simultaneously. But I think we're gonna add that feature. So having the ability to load from multiple folders, that simplifies a lot dealing with multiple folders. And yeah. I just have to call the PageRank from NetworkX. I have it here. If I run, since I restarted, I have to load the dataset again. So edges are coming in. Great, and if we run this, so if you remember last time, this took I think like 25 seconds or 26, something like that. So it will take that here as well. And while it's running, I'll just compile Memgraph here in the debug, in the release mode. And that's also possible to do by calling cmake -d cmake build type equals release. So that will reconfigure the project in the release mode. And let's recompile. And if we check the size is right. So 37 kilobytes of memory for that module. Let's go back here. And yeah, it says 25.7 seconds, which is a lot bigger than the one. So it's like, I would say, like 100 times more time to calculate the same thing. I mean, it's not actually the same, so we are returning here the entire nodes, and the results might be slightly different based on the parameters and the actual calculations because of the normalization and basically based on implementation, but more or less like the results should be similar in general. And yeah, just to rerun that with the release mode. If you remember, in the debug mode it was 50 milliseconds, and if I go here, I have to stop the Memgraph again and load the PageRank module again, and I have to also import dataset again. Yeah, I could also import the snapshot, and that would be faster, but yeah, didn't do that. This should be fine for now. So the dataset is in, and if I run, so yeah, edges are there, and let's just calculate PageRank. And on the release mode, in the release mode, it actually takes, the algorithm actually takes 16 milliseconds to complete, which is, let's say, 3 times faster than the debug mode, and a lot faster than the Python time, Python NetworkX time. That's about it when it comes to the comparing, and that's just single-threaded implementation. So we basically implemented the easiest possible, and with zero polishing. I mean, just a little bit of like reserving the space for node vector and stuff like that, but nothing major. I'm sure that code could be polished a lot more. And that's it. What I've prepared. I actually really like the preparation, because I can really nail all the important details and then just present. So I think I'm gonna keep that in the following streams as well. And yeah, since we have time, I think I'm gonna try to compile the Mage implementation of PageRank, which is actually parallel. So it has like polished implementation of parallel PageRank, and we'll try to do that now. So, and I didn't prepare that, so that might take a bit longer, but yeah. Let's go here. This is for later, and Mage. So we actually polished a bit the repository, but I'll just go here and take. We still didn't merge everything, so it's initial PageRank module. The code is still under code review, but should be fine. If I have some issues, maybe I'll just stop doing that and do that next time, but we'll see. Where to do that? Let's do it here. I actually have the Mage repository here. Let's pull. Okay, I have. Oh, uh-oh. Did I now? Maybe it's fine. Okay, it's good. Okay, great. And let's go to the CPP part. And I think we can do just here mkdir build cmake. It works, and let's compile everything. It's done. Let's just be sure. Okay, I think we are good here. Just to check that one more time. So if we go equals debug, and if we ls PageRank module, so PageRank module has 1.9 megabytes. The implementation is a lot bigger, so that number is, I think, okay. If we change to the release and compile it again, and then just print this, yeah, and this is 100 kilobytes, which should be fine. Okay, let's go in here and just print directory. So that's the PageRank module. We have the where am I? Here. Let's stop this and then just replace this build directory with this one. So build PageRank module, yeah, from the Mage. Okay, should be fine. If I check here, I have PageRank and pattern PageRank. Let's ignore this for now, but I'll just take the PageRank one. I'm really curious what will end up here. I mean, parallel implementation could be. It doesn't mean if something is parallel or concurrent that it will be faster. So it might actually take the similar time, but if that's the case, in the next stream I'll try to do on a bigger dataset, and then the difference should be visible. Okay, so we don't have anything in the dataset. If we go here, I have to import data again. So 0 is inside. One more time, I think, one more time. And we good. Okay, that's good. And we have the dataset ready. One more look in the lab. All good. Let's go back here, because this terminal here is showcasing, has the time. So I'll move myself here. Actually, no. Let's do here, and let's do this. Okay, and then I have to run the actual. Have to actually run this. Okay, if I put, sorry. Call CPP PageRank module PageRank. Yeah, so we actually have something strange here. As always, unexpected things happen. So we actually got nonce instead of some real numbers. That's, I think, bug in the implementation. Yeah, in the implementation. So actually we have one more test case. Haha. Okay. Yeah, I'll check. I'll double check that. Won't go now there. I'll check that and fix during the week. But yeah, it took 20 milliseconds, which is slightly slower. But as I said, so, and that this could actually be related to serialization and stuff like that, to the baseline overhead that each call has. So let's try one more time. It's actually pretty consistent. Yeah. Probably for that small dataset, the parallel implementation has more overhead than benefits. So next time we try, hopefully I will be able to fix, or someone from the team will be able to fix the implementation, and we'll try on a bigger dataset. Yeah, 0 questions. So please, if you have something to comment or add or suggest, feel free to do that. Because I think we are more or less good for today. Hopefully I've managed to present the scale and speed differences between Python and C++ implementation of PageRank. Will continue. I plan to do similar with all the algorithms, so eventually we're gonna catch them all. I can maybe switch back to the camera and talk a bit in general. Yeah, still no questions. So that's more or less it for today. Next time, I'm thinking about doing PageRank, the more scalable example again, or I had the plan before to start implementing Rust modules and build that infrastructure and build have a bit longer stream about that, because it will take some time and the process is interesting, and I think I can showcase the entire query modules API. But yeah, we'll see about that. Basically, these two topics are possible. So if you have some preferences, please leave them in the comments, or maybe I will create a poll or something about that. That would actually be nice. What else? I think we good. That's it. If there are no any questions, so yeah, thank you again for watching. Please like, share, subscribe, and yeah, see you next time. Bye bye.